Now that I'm done with my little spiel. We're going to sort of debrief launch day. How many of your launches went exactly as you anticipated? Nothing was different. There were no weird factors that influenced your objects, and you rocked it. Okay. with the smirk of a winner. How many of you did any calculations before designing? I'm going to guess that the number looks a lot like that. Okay, I would be correct. That's what I thought. So remember I said part of my job, I think, is to get you to start considering the math prior to the design rather than just fiddling around with it. Because you can just fiddle around with your little ping pong ball launcher. You can't if you're designing a bridge. I don't know, give me a bunch of steel, give me a bunch of concrete. We'll get it done. We'll figure it out. What's interesting is, do you know who Frank Lloyd Wright was?
No.
Really?
That sounds really familiar.
Oh, Frank Lloyd Wright. Hold on. Brilliant visionary, doing like really radical modernist architecture, cool stuff. His engineering, not so much. Architecture is engineering plus art, and architects design the world, and that's great. You see all these things? These are called cantilevered terraces, and there's a whole lot of physics behind getting that cantilever to work. Unfortunately, Frank Lloyd Wright's grasp on the physics behind the design was not as strong as we would want it to be. So by the 80s, parts of the house were actually falling down because they were under-engineered. It looks really cool. Oops, it'll kill you. So seriously. And when you look at like historic building designs, there have been buildings that, were they engineered to today's standards, wouldn't go. And some of them are fine, and some of them are not, and they kill people. Here's an approximation of, some random student's catapult. And it's going to launch, and it's going to strike here, and it's got a nice 90-degree angle for launch. Maybe it's a 75-degree angle for launch. I don't know what the final is. If we know how far that goes, could we figure out initial velocity? If we know the initial velocity that it's capable of, could we figure out how to dead center it every single time? Oh yeah, we could. Now, many of you had really surprisingly high launch angles, I will say. I will, without naming names, but it's a small group, you all know who's who here. We had one that was a little bit terrifying, had it been launching a more massive object. Okay, now we're just all looking at the light-up hat. So yeah, Lauren and Colin, your device launched with what we will call a terrifying speed. The initial velocity on that puppy was rough. It was frightening. We may yet. We'll see. If you were actually conducting siege warfare, that thing would take down a castle wall, no problem. Not with a ping pong ball, but it was terrifying. And it also had a darn near 90-degree launch angle. It was zooming. I mean, it was almost a horizontally launched projectile. It was so fast that I actually couldn't always reliably figure out what it hit, and I had to go back and review frame by frame to get your scores. I mean, you know this. This is no secret. It was terrifying. Utterly frightening. Horrifyingly fearful. I was. Anyway, I'm glad we were launching something that was low mass. It was scary. Now, on the other end, and I'll shrink this little one, we had one device that had a very high launch angle. And again, I'm not naming any names, but it's a small group. And we had these beautiful arcs. You think you might recognize that? So we had sort of like competing design ideas here, because in one case, and I don't know if this was the goal, to attach numbers to it, it certainly appeared that the attempt was to maximize launch velocity, terror, death, destruction, mayhem. And in the other, we were really maximizing height. If part of the goal had been to get your shot very, very high, this one would have been fantastic. It also gave the team in question, this one, a lot of control over delta x that I'm not sure was as present here, because there was a limited ability to control velocity. I guess that's it. Okay, so anyway, as you're doing calculations, just consider these things. Consider these kind of technical terms for the differences that you're seeing. We'll talk more on Monday. If you are getting stuck on problems, see me in study hall.